Hello, I am Sunita. Welcome to my class. Here I am going to discuss JPSTR science topics according to the syllabus. Here the topic is current electricity. In this one we will study about electromotive force, internal resistance of a cell and grouping of cells. Let us discuss in detail EMF, terminal voltage and internal resistance of a cell in this class. Electromotive force EMF. Potential difference between two electrodes or terminals of a cell when no current flows means open circuit. Consider a circuit here. This is the cell and small r it will represent a internal resistance. This internal resistance it will be present inside the cell, but here to understand we wrote outside the cell. Small r it will be the internal resistance, it will be present inside the cell. That one you have to remember. Then these two is the terminals of a cell. Then this capital R is the external resistance of a circuit. Then here EMF means potential difference between two electrodes or terminal of a cell. The potential difference between two terminals of a cell or two electrodes when no current flows or open circuit. In open circuit the current it will not flows. When no current flows in the case of a open circuit, then the potential difference across the two terminal of a cell it will create a EMF. That one we will call it as a EMF. It is represented by a symbol E and units is volt. Here consider the another definition. The work done on a unit positive charge in moving it across the external as well as internal circuit. Here this is the internal circuit, this is the internal resistance, this one is this capital R is the external resistance. Here EMF means the potential difference between the two electrodes or terminal of a cell when no current flows when it is a open circuit. That one you have to remember. Internal resistance of a cell, it is represented by small r. It will be present inside the cell. The resistance offered by a material of electrolyte to the flow of current inside the cell. Resistance is nothing but a opposing force. It will oppose the movement of an ions inside the cell and it will oppose the flow of current inside the cell. Let us discuss the factors on which the internal resistance of a cell depends. Let us discuss one by one in detail. First one, nature of an electrolyte. When you are having strong electrolyte, you know strong electrolytes are good conductor of electricity. When you are having good conductors, then ionization it will take place very easily. When ionization is more, you are getting more number of ions. When the number of ions is more, they can move very easily within the conductor. Therefore opposing force it will be very low, then resistance it will be more. Resistance it will be less when you are having a strong electrolyte. But consider a weak electrolyte. Weak electrolyte is a poor conductor, then number of ions getting ionized is reduced. Then collision between the ions is more, then resistance it will be more, opposing force it will be more. That one you have to remember. The next one, area of electrodes. Here consider two electrodes, area of an electrodes. Here if the area increases, then conduction, then the ions they can easily get deposited on the electrodes. You know in an electrolyte ionization takes place, then after ionization the ions they will get deposited in the respective electrodes. If the area is more, then easily that ions they will get deposited easily. Then resistance it will be less, opposing force it will be less when area is more. Third one, distance between the electrodes. As the distance between the electrode increases, as the distance increases, then the ions, this is the ions they will collide very easily. As the ions they will start colliding, then movement of ions it will be restricted. As the movement restricted, then resistance automatically it will be increases. Then fourth one, concentration of an electrolyte. As the concentration increases, then ionization decreases, number of ions it will be get decreases. Then if the number of ions decreases, then collision between the ions it will be increases automatically. Resisting force it will be increases, resistance it will be increases. Fifth one, temperature of an electrolyte. As the temperature increases, ionization also it will be increases. As the ionization increases, resistance decreases. As you are getting more number of ions they can freely move within the cell. Then restriction force it will be less, then resistance it will be less. Then this one is very important factor on which the internal resistance of a cell, this one you have to remember. Internal resistance is always in series with the external circuit. This is the internal resistance R, it will be present inside the cell. Then here this internal resistance it will be connected in series with, this is the external resistance R. Therefore current inside the cell it will be equal to E divided by R plus R, sum of the two resistors. Terminal voltage or terminal potential difference V. Potential difference across the terminal of a cell when current is drawn from a cell in case of a closed circuit. Let us discuss in detail terminal voltage. Let us consider the circuit here. This is the battery. This is the internal resistance. It is indicated by small r. Its value is 1. This is the external resistance. It is indicated by capital R. Its value is 2 ohm. Then this internal resistance it will be present inside the cell. You know that one. Then E it will be equal to 9 volt. E is nothing but a EMF. What is mean by EMF? Electromotive force. When the circuit is open circuit means the current it will not flow inside the circuit. That one you have to remember. Open circuit means the current it will not flow inside the circuit. When the circuit is open circuit, then potential difference across the cell. When the circuit is open, then you will get a EMF. EMF it will be equal to 9 volt. Then here EMF is 9 volt. Then calculate the how much current it will flow inside the circuit. You know the formula. I it will be equal to E divided by R plus R. Here EMF is 9. Substitute in this equation. I it will be equal to 9 divided by. Then resistor, sum of the resistor 2 plus 1 you will get 3. 3 ones are 3 3 the it will get cancelled. You are getting a final value 3A. Therefore the current it will be equal to 3 ampere. Therefore 3 ampere of current it will flow inside the circuit. If you consider any point in the circuit, then you will find out 3 ampere of current it will flow inside the circuit. Then here you know the formula V is equal to IR. Calculate how much voltage this resistance it will get, this external resistance it will get. You know the formula V is equal to IR. I is 3, R is 2, 3 2s are 6. Here the external resistance it is getting 6 volt. Then calculate for internal resistance also. V is equal to IR. I is 3, R is 1, 3 ones are 3. Therefore this internal resistance it is getting 3 volt. Then here one thing you have to remember, otherwise one thing you have to observe. Here the EMF is 9. EMF means this cell it is telling in the beginning I will provide 9 volt. But observe here this external resistance it is getting only 6 volt. This then remaining 3 volt, this internal resistance only it is consuming. This one you have to remember. Then come to terminal voltage. Potential difference across the terminal of a cell in closed circuit. Terminal voltage means always you have to remember in a closed circuit. In a closed circuit the current it will be flowing inside the circuit. Then this is the closed circuit. Here you are having the external resistance. Then here you are having the two terminals. Then potential difference across the terminal of a cell in a closed circuit, we will call it as a terminal voltage. Here terminal voltage, it will be equal to 6 volt because this is the external resistance. 3 to the 6 volt you will get. Then this is the terminal voltage. Don't get confused between EMF and terminal voltage. Once again I will explain. Listen here. EMF means when the circuit is open circuit, then the current, it will not flow inside the circuit. Then that case, the potential difference across the terminal of a cell, we will call it as a EMF. Okay. When the circuit is closed circuit, then the current, it will flow inside the circuit. Then potential difference across the terminal of a cell, we will call it as a terminal voltage. EMF means when the circuit is open circuit, when the current is not flowing, then that case you will get potential difference. That one is the EMF. Terminal voltage means when the circuit is closed, when the current is flow, then the potential difference across the terminal of a cell, you will get a terminal voltage. These two are very, very important. You have to remember these two. Then one more thing here, EMF, it will be 9 volt. This external resistor, it is getting only 6 volt. This internal resistance, it is consuming 3 volt. Therefore external resistor, it is getting only 6 volt. That one also very, very important. Let us consider how to calculate terminal voltage in different situations. First one, discharging of a cell. Consider this is the circuit. Then this is the current I. The current I is discharging from the cell. In this case, terminal voltage is given by E minus IR. Then terminal voltage, simply you can write it as V. V is equal to E minus IR. In this case, discharging of a cell means the current is coming out of the cell. That one you have to remember. Next one, charging of a cell. Here the current is given to the cell. Otherwise the cell is getting charged because of the incoming current. In this case, terminal voltage, it will be equal to E plus IR. Then here terminal voltage, it will be more than the EMF in this case. In the case of a charging of a cell means the cell is getting more charge. Let us discuss in detail here grouping of cells, series grouping, parallel grouping, mixed grouping, one by one. Let us consider first one, series grouping of cells. Here the cells, they are connected in series. Series means the cells, they are connected in a row. They are connected next to each other in a single row. Then here each resistor is given by R1, R2, R3. Here you are having 3 resistor, internal resistor. It is given by the name R1, R2, R3. And here you are having 3 cells. That cells, it is producing the EMF. Then EMF is respectively E1, E2, E3 in each cell. Here equivalent internal resistance is represented by R equivalent. Then equivalent EMF is given by E equivalent. Combining all the 3 cells, you can write like this. Then here you can observe in each cell you can find the same polarity. Then here equivalent EMF, it will be given by, in this formulas, it is valid only the cells when they are arranged in a series. Then E equivalent, it will be equal to E1 plus E2 plus E3. Then R equivalent, it will be equal to R1 plus R2 plus R3. Then next case, if the polarity of any cell is reversed, here polarity of each cell is same. Here if any one cell, if the polarity is reversed, then what is the change in the formula? Let us discuss here. Here also we are considering 3 internal resistance R1, R2, R3. Here also 3 different EMF, otherwise 3 cells, they are producing 3 different EMF, E1, E2, E3. Then here first cell, second cell, they are having the same polarity. negative, positive, negative, positive, but polarity of the third cell, it will reversed, it will become positive, negative. Then here E3 is reversed, the polarity of E3 is changed compared to remaining two cells. Then here equivalent EMF, it will be equal to E equivalent, it will be equal to E1 plus E2 plus minus E3. Here the sign it will change because this E3, otherwise this cell, the polarity of this cell is reversed. The polarity of which cell it will get reversed, that cell it will carry a negative sign. Then here equivalent resistance, it will be equal to R1 plus R2 plus R3. But here one thing you have to remember, equivalent resistance, it will not change, the formula it will not change if you reverse the cell also. If you change the polarity of the cell also, equivalent resistance, the value it will not change, only the equivalent EMF it will change. Then the cell, which one it will get reverse, only that case you have to change a negative sign. This also very important. These two are very important formulas you have to remember. Next, parallel grouping of cells. Here each cell, they are connected one below the other, and they are connected by two terminals, terminals A, terminal B. Then this one it will equivalent to internal resistance, equivalent internal resistance and equivalent EMF. This one it will gives. Then formula, equivalent EMF it will be given by E1 by R1 plus E2 by R2 whole divided by 1 by R1 plus 1 by R2. Then internal resistance R equivalent, it is given by 1 by R equivalent, it will be equal to 1 by R1 plus 1 by R2. Note, if identical cells are connected, if these two cells are identical, then you have to use this formula. E equivalent, it will be equal to E, then R equivalent, it will be equal to R divided by N. This is also parallel combination of cells. If polarity of any cell is reversed, this polarity is same, then this polarity of E3 is reversed. This is also same. These two, E1 and E2, they are same polarity. The polarity of E3 is reversed. Therefore, in this formula, in place of E3, you have to replace a negative sign. Then E equivalent, it will be equal to E1 by R1 plus E2 by R2 minus E3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. There is no change in internal resistance. 1 by R equivalent, it will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. Mixed grouping of cells means it is a combination of the cells which is connected in series also and also parallel also. Here you can see in this circuit, here each row contains n cells and total number of rows is m. Then total number of cell is m into n, because n is the number of cells. Then m is the total rows, multiply m into n, you will get total number of cells. The equivalent EMF is n into E, because you are having n number of cells, therefore equivalent EMF is NE. Equivalent internal resistance NR divided by M. R equivalent, it will be equal to NR divided by M, because each row it contains n number of cells. Then internal resistance, it will be equal to N into R. Then here you are having total number of n, total m number of rows, therefore divided by M. Equivalent internal resistance, it will be given by NR divided by M. Remaining these three I will explain in the next slide. Let us consider the simple circuit here. Then here I current, it will be equal to equivalent EMF divided by R external resistance plus small r equivalent internal resistance equivalent. It will be equal to NA divided by capital R plus NR divided by M. Here, next important one, condition for maximum current or maximum power. At what condition you will get maximum current or maximum power? Condition is net internal resistance, it will be equal to net external resistance. If this condition is valid, in that case you will get maximum current or power. Internal resistance, net internal resistance, it is given by NR by M. It will be equal to external resistance R. I maximum, substitute this value in this equation, then Ne divided by capital R plus, in this place replace capital R plus R, it will be equal to 2R. This it will be maximum current. I maximum, it will be equal to Ne divided by 2R. Let us verify with an example here. I maximum condition, it will be internal resistance, it will be equal to external resistance. 0.2 ohm, it will be equal to R. Then I substitute in this formula. EMF is 4 divided by 2 into R value is 0.2, 2 into 0.2, you will get 0.4. When you simplify this one, you will get 10 ampere of current you will get in this case, maximum current. Thanks for listening my class. Send me your valuable feedback.